Alright, so in this video we'll talk about convolution. So in the very first video I had mentioned how Z transform makes convolution especially very easy. So we'll go over how it does that. So if you remember how a signal works is you have a signal x of t that gets converted from C to D, so from continuous to time, and so you get x of n. And then it can go through various filters or any other kind of processing. So that's your computer or your system where you do all the processing, and then you get y of n, and then this goes from a D to C converter, and then you get y of t. So this is again, so you have x of t, and that is the input signal which goes through a continuous to discrete converter, so you get the discrete time signals. And here is where all the processing, so if there's any filtering or any other kind of processing that has to be done, this is where it takes place, and then you get y of n as a result, and then this again goes from a discrete to continuous converter, and you get the analog y of t signals again. So now in this case, how convolution, so the convolution is the process of having y of n. So this process is generally the convolution part, where you get yn in terms of xn and the filter. So generally if the filter is h of n, you have yn equals to x of n times h of n. But the convolution, not just multiply, but convolution of these two. So how it's really done is, let's go over an example of the traditional way, and then I'll show how it's done in the Z domain. So in the traditional sense, say you have a signal x. So let's say these are the coefficients for x and n. You have 0, you have 1, you have -1, +1, -1. And then for h of n, you have the coefficients 1, 2, 3, and then 4. This is plus. So when you do a convolution, you have to multiply this by all of them, then multiply this by all of them, multiply this by all of them, this by all of them, and then add them up. So you get, for the first line, you get 1 times 0 is 0, 1 times 1, -1, 1 times 1 is 1, 1 times -1 is -1. And then for 2 you get, and then you leave a space here, and then for you get 2 times 0 is 0, then 2 times 1 is 2, 2 times -1 is -2, 2 times 1 is 2, and then -2, so on. And then you keep doing this, and then basically you add them up. So it's a very tedious process, especially if the signals are, if it's a long signal. So in the Z domain, how one can do this is, if you have a signal x of t, and you have so this already convert x of z, sorry. So you have already translated this to the Z domain, and you have also translated the filter or the h part in the Z domain. Then you can just say y of z is equal to h of z times the x of z. So instead of doing multiplication for each row, you only multiply it once as polynomials. So let's go over an example of how this is done. So say you have a signal, I'm sorry, let me keep the camera properly. Okay, so let's say we have x of n equals to this. So if this is the x of n, and if we convert this to the Z domain, we will get so again, coefficients match, and there's the time period, -1, -2, -3, -4. And then say we have a Okay, and then we have the filter. That's the formula for the filter. Let's say in this case h n this plus 2 n minus 1 plus 3 . Alright, so when this is translated, we will get 1 plus 2 to the z minus 1 plus 3 to the z minus 2 z minus 3. So this is what we will get when we translate this to this. So now we have x of z, we have h of z, so now we have to calculate the final output, the y of z. So this is just multiplication of this times that. So all you have to do is do z minus 1 minus z minus 2 plus z minus 3 minus z minus 4 multiplied by 1 plus 2z minus 1 plus 3z minus 2 plus 4z minus 3. So you can do this by saying, okay, so this is z minus 1 multiplied by everything, so you'll get z minus 1 plus 2z minus 2 plus 3z minus 3 plus 4z minus 4, and then you will multiply this by everything, and so on. So finally you can add them up all together, and so this is plus so on. So I'll multiply this by everything, and then we'll multiply this by all the values on this side, and so on. And I'm not doing all the calculations, I'll leave that for you, but I'll just show you. So once you do all this, you'll get probably like terms. So like here you have z to the power minus 2. If you multiply this by this, you'll also get z to the power minus 2. So you could easily combine them together, and the final result in this case you will get z to the, here, hold on, one second. Get z to the minus 1 plus z to the minus 2 plus 2 to the z minus 3 plus 2 z minus 4 minus 3 z to the minus 5 plus z to the minus 6 and minus 4 z to the minus 7. So as you can see, we converted from time domain to z domain, both for the x of n and h of n, and then all we had to do was multiply them. So this just became y of z just became h of z, this part multiplied by x of z. So this was the x of z, this was the h of z, and then we multiplied them together. I didn't do all of the calculation, but this is what you will get finally. So this is how you can do convolution in the z domain.